So I won't yap on any longer. I'm going to introduce my first speaker. The way lightning talks work is somebody has a 5-minute time slot, and after the time slot, we will let them know that they're done, and then they move on, and then the next person goes up. If you have any questions, we don't do a Q&A right now, but I definitely think they are open to talking afterwards. All right, the first person is Jer, I'm so sorry. Jer, and he's going to talk about hacking IP cameras. A big applause to Jer.
Hi, welcome everyone. This was supposed to be a 30-minute presentation, and it got changed to a lightning talk. So we're going to speedrun the entire thing. So bear with me. My topic is IP camera hacking. This has been an interest of mine for a while, and I'm going to explain to you, going to walk you through the process and what the impact is. So what are IP cameras? IP cameras are any network-connected camera. They're sometimes over Wi-Fi, sometimes they're over Ethernet, outside, inside, businesses, government buildings. You see them everywhere. The use case is mainly security, monitoring, which people install them outside or inside to monitor their business or their home. The main protocol is RTSP. It's a protocol for streaming the video feed from the camera to another application. That could be an app in the case of things like Ring, or in the case of many security cameras, it's a web portal where you can log in and view your camera. How to find cameras. The main things are tools like Shodan or Census, where they're easily identified. You can look up the RTSP protocol in most of the IaaS applications, and you'll get all the cameras running RTSP. Or you can search for certain brand names, like Dahua or Hikvision or Axis. These are the more common ones, the Dahua and the Hikvision. They're the cheapest ones, they're Chinese ones, but they're also the most vulnerable ones. So we'll get into that. Some of the cameras, they also leak metadata images. So they cache a screenshot of the camera every 24 hours. And oftentimes it's exposed. So if you want to know where a camera is or what the view of the camera is, you can go in and try to capture that screenshot. In the cases of Shodan, oftentimes it also just displays it in the actual web page. So it's super easy to find where these cameras are. Getting inside the cameras, there's the most common attack is default passwords. I would say if you spray for default vendor passwords, you're still going to get like 30 to 40% success rates in most countries. Another one is brute forcing the actual portal. Here's a list of most of the common brands' default passwords and usernames. But the portals often have lockout policies. You can also brute force the RTSP protocol itself. Oftentimes, the web portal is authenticated, and the RTSP protocol is not. So if you log in straight to the RTSP protocol, you might still gain access. And also, the RTSP protocol almost never has a lockout policy. So it's way easier to focus on attacking the protocol instead of the application. You also have public exploits. There's a lot of one. This is the most common one for Hikvision. It's a Chinese backdoor found in 2018. Also, the reason people probably shouldn't be using Hikvision cameras, because it's happened 4 times, and every time they said, it's a debug feature, we left it in on accident. So trying public exploits, trying brute forcing, and attacking the main RTSP protocol itself are the main attack vectors. And you're probably going to get, depending on the country, between 70 and 90% of cameras. This is the main impact of hacking IP cameras. Of course, it's an invasion of privacy. If it's in your home, it's scary, you feel violated, but there's also risk on a national level. Here are some examples from in Ukraine. This is the Kerch bridge. It has the hacked camera here has been used to target the bridge for airstrikes, drone strikes, and also logistical movement of trains and military equipment. Here's another example. This is one of the highways in Russia, where there's a detection software running, seeing if there's military vehicles. They come through, they monitor them, and when needed, they can strike. So these cameras can lead to real-world impact, and in some cases, even destruction and death. Automation, there's some tools to automate this. I won't go through any of them because I have not enough time, but I'll go through two. Ingram, it's a Chinese tool. Don't blindly trust it, but rewrite it if you want. It's an automation framework for automating the exploits and the brute forcing, and it will combine them and go through them quickly. Another one is RTS Prebrute. It's a Python library that just does the brute forcing in a faster way than something like Hydra would, because it's focused only on RTSP. That was it.
Wow, congratulations, you saved 30 seconds. Thank you very much. So big applause again. And then our next speaker is Vista, and he's going to tell us about Container Lab, a modern tool for network emulation and labbing. Interesting, okay. And here's a timer. Ding, ding, ding. Ding, ding. Okay, have fun.
All right. Hi, my name is Vista, and I'll be talking about Container Lab, an emulated network labbing tool. So, what are these emulated network labs useful for? If you want to play around with the sort of equipment that your ISP or local data center might have, you probably don't want to take a look at the ticket prices because they are very expensive, but rather you want to run these as virtualized equivalents. And thankfully, the vendors provide these equivalents. So to actually run these, you need an emulated networking lab tool. Container Lab is not a novel solution, and it really builds on the shoulder of giants. But these tools, these old tools, they are very GUI-oriented, and they really are not designed for automation. They are usually shipped as an appliance OS and have quite a bit of dependencies. And so with Container Lab, we decided to take a different approach. We are using DevOps principles, where we provide a declarative topology file to the tool, and the tool figures out how to deploy that emulated network lab topology into your system. And so the thing is, we use this approach because we don't want the user to deal with the how, but focus on the what. What do you want to model? What do you want to lab with? And Container Lab supports containerized network OSs, like the OSs that run on those big boxes, but containerized. They are generally have a much smaller resource footprint, and they have quicker startup times than the virtualized equivalents. And they are easier to emulate on non-x86 systems as well. And the general trend is that these are the type of network OSs that the industry is moving to. You can also leverage the existing container ecosystem and use existing Docker images or container images to run open source routing daemons or telemetry stacks, or even run like traffic generators like iPerf in your emulated network topology. And finally, of course, we also provide a solution to run VM-based network OSs in Container Lab as well, because we recognize that many users still need these. So to actually get started with Container Lab, we need to install it first. It's a single binary, so it's a single command to install. We provide a very handy curl pipe bash, but of course you can compile it yourself or download the binary and install it yourself. And the only requirement of Container Lab is to have a working containerization runtime on your host. And to write your own topology, all you need to do really is to define a node at least. A node has a name, a kind, and an image that ContainerLab uses to spin up the node. And you can connect these in an arbitrary topology using either the Linux interface name or the network OS's own interface naming. And to deploy it, we run ContainerLab with a single command and have a working topology where we can SSH or we can use Docker exec to get into the container. And I did mention that ContainerLab is an automation focus tool, but it also has a GUI in form of a Visual Studio Code extension. And recently, 2 students at the Ostschweizer Fachhochschule, Kian Gribi and Tom Stromer, have released Antimony, which is a web UI-based front-end for ContainerLab. And by doing so, they have completed their theses, so congratulations. And there is also an API server you can spin up in a single command. And we have community-provided labs, of course. And it's really easy to find ContainerLab topologies on GitHub as well. You can just search for the CLab topo topic. And we're also looking for contributors to ContainerLab. It's a project written in Golang, and we have plenty of open issues. So if you would like to contribute, please do so. We have some documentation, and we have a very lively Discord chat group for the actual project where you can communicate, where you can talk with fellow project users. And that's it.
Big applause. Thank you so much for your enlightening talk. The next person on stage is Walter Belgers, and he is going to talk to us about reverse engineering in 1991. Let me see if I can pronounce this right. Megatronic Lock. Are you ready?
I am ready, yes.
All right, a big applause, please.
Wow. Hi, everybody. You must all be morning people being here so early. It's great to see people here. I'm Walter, I'm a hacker, but I'm also a lockpicker, and I like to do some small projects. And I'm going to talk to you about the LIPS Electro, which is a electromechanic, or as they called it at the time, Megatronic Lock. So I came to buy a few of these locks. This was a picture from the press introduction in 1991. This is an actual lock, and this was made by Dutch lock company LIPS in a multi-year, multi-dollar project. And they had a goal of creating a more sophisticated lock that has the look and the feel of a traditional lock with a standard key. As you can see, the key is looking rather standard, but it has electronics inside for added security and added functionality, like being able to program keys and deprogram them. Because if you have a large facility with a lot of users and a lot of keys, that's really nice to have. So if somebody loses the key, you can just reprogram the key in the lock and give them a new key. So I got these locks. I actually got 3 of them, and none were really working. One had one key that worked, but nothing else worked. And I started by investigating this, looked at public sources, but also did some reverse engineering. Here you see keys, and these are colored. And the way this works is that if you have the green key, you're the boss. You have the key that can enable other keys to work in the lock. The red key is to disable a key in the lock. And then there's a blue key for special time zone access. And what's interesting is that that black blob over there, that actually holds a IC. And that's a custom-made chip. And that was really super state-of-the-art in 1991. They specifically created this. And if you look closely, I can point, you can see that here on the edge of the chip, you see an antenna. And this works with an electromagnetic field. And it was patented. So they got a patent for this thing on the chip. And actually it's like an NFC card right now, right? But in an NFC, if you have a tag, you normally have a chip and then you have a separate antenna. Here it's integrated on the IC. So that's cool. This is 3 by 3 millimeters. It's in there, it communicates with the lock. And then you have the regular user keys that you can program to work on a specific lock. and they are in different color codes. Now, the lock contains some mechanical stuff. There's also patents there on how it works, but in here is the electronics. Here you see it on the PCB, and this was also interesting because they had to make it really small because one of their one of the goals was to create a very tiny lock as big as the normal one. And they used SMD components. There's a microcontroller unit, an 8051, actually 8052, 2 kilobytes of RAM, and there's a 8 kilobyte EEPROM that holds all the configuration data. I soldered them off, so that's a new skill I had to learn. Was able to take out the 2 kilobytes of RAM and started looking at that with a disassembler. So I used IDA, and this was really tough for me. I'm not really a programmer, so I spent a lot of time trying to figure out how it works. But yeah, I didn't get the locks to work, so then I took a different approach. I took one of these locks totally apart, and on the back side is the EEPROM that I hooked up via wires, via a socket that I can exchange the EEPROM. And what I did was I just wiped the EEPROM. Then I got a working lock again. I could initialize it with new keys, and I could just program some keys in it, take out the EEPROM, see what has changed in the EEPROM, and put it back, and in that way try to gain understanding. And that eventually led me to get a bit of understanding, enough to be able to get all locks working again. But there's still some things unknown, like there is some configuration in the EEPROM that I do not know exactly what it's about. And also these locks, the later ones, have a RS485 serial connection that I was not able to get to work. I think it's not enabled in these locks by default, so I need to change some configuration to get that to work, and that would be really interesting. Also, there is this program box that has something that looks like a key. You put in the lock, and it can actually communicate over that connection that normally the key uses. So that's really a neat feature, but I have never seen a program box in real life. So the state now is I talked to some people, they said, no, you should not use IDA Pro, you should use Ghidra, which produces much more readable results. Yesterday, or actually this morning, somebody told me, why not use Binary Ninja, so I have to look into that. And I want to get that serial connection working. That would be really interesting. And maybe even find a program box. So that's also my question to audience or people on the stream. If anybody has more information, contact me. The QR code links to a 50-page paper that I wrote about the project, and also if you go to the wiki, to the program, the link is on there as well in this lightning talk session. So that's it. Thanks.
Okay, thank you very much. I have two small announcements. If you're a Lightning Talk speaker and haven't checked in with us heralds, please do so. And the other announcement is if you are an Angel shirt hours are now down to 6. So if you have worked 6 hours and have it in the system, get your Angel shirt if you don't have it already. And now, on to the next speaker. This is Go Church, and I'm really curious. This is how furry VR chat broke my brain.
Is it working? Hello? How are we doing? Okay. A bit nervous. Yeah, so until about last year, I was a pretty normal VR software developer doing a lot of work in Godot. I haven't found anyone who does VR or Godot anywhere in this campsite, so I think my tech is even more far out than all you guys do. And I sort of gave presentations about doing wind tunnels, and I showed that off at FOSDEM earlier in the year. And I also do a lot of going to live VR theater, which is a really cool thing. I always try and get people to do this, and you get some actors, they take you on this big journey, and it's a lot of fun. And I also go to all the VR art exhibits, because that's where the cutting edge stuff is going to be, and it's much easier to steal other people's ideas than think of everything yourself. So this is an example of one. You kind of sign up for this, they give you a ticket, and then they give you a big tour around a beautiful world, or they give a show or something or other like that. So the issue is that when I signed up for this thing earlier this year, I thought this was just going to be another thing. I thought I knew everything about VR, because I've been doing it so much in many different ways. the algorithm, the YouTube algorithm, didn't think I was a furry. I never had a furry YouTube video coming through. So something strange happened here. So what happened was they started out doing these sort of new player nights to try and welcome people earlier in the year, and they were useless. So there's me, circled in the corner, using the sort of avatar that new people always use because, and everyone else, they're not new players. They all know each other. They're talking to each other. I was there for 2 hours, completely on my own, not speaking to anyone, except when they like take the big picture and stuff. So I was pretty miserable after that time. And it turns out that I really kind of need this structure, like those performances where they take you along. But when you're left alone, like your first day in school, it was terrible. So sometimes there's this guy here, this dog guy. He keeps an eye out for new players occasionally. And so he picked me up the next month, and he invites you to a few games, and then you get to meet all of his friends, like this dragon guy I've got to know really quite well in the last few months. And at this point, I decided I better make my avatar not quite so beginner, and so I put the Godot logo on the back so I can fly the flag, even though nobody knows what it means. So, but it makes me nice. Then another very notable new player night was in May, and I sort of passed it forwards. So you can see this little guy, Ray, is using the avatar all beginners use, and I spotted him coming in through the door and sort of cowering on his own. In a room full of people, and I sent someone to go speak to him because I'm too shy to talk to him. And this other guy, Toby, heard that he was a new player. He was a new player as well, and they sort of hit it off. And you could see them over the next few days and weeks meeting up every night in VR chat, and they were really cute to go and see. They let me in to be with them occasionally. And then the actual convention began. This was 4 days. They had 26,000 attendees at about $30 per ticket. And it was like dealer's den, movies, panels, discussions, all the sort of things you get at a convention, but just loads and loads of people. And at the end of it, there was this big fireworks show, and it was delayed by an hour, so we had enough time to really goof around, and this dragon guy could fly us up to the top of this roof, and we all had a nice view. And really, this is one of the happiest moments of my life. I kind of felt like I had this 1,000-volt battery in my chest the whole time. It was quite something. So I was going, what the heck is going on? I've never seen anything like this, like since I was 12. So firstly, you've got 3 things. You've got these avatars that are not at all human, and all the research is trying to make self-similar avatars that look the same as you. But that's just something that grew up around you. Who knows that that's actually what you feel comfortable with, when you're given the choice. And the other thing was I was seeing these friendships being made almost instantly during this narrow window when we were all new. And, the research and the sort of essays never seemed to reflect what I was seeing, including this one here, which said, it takes 50 hours to make a friend. You're not spending 50 hours with someone unless they're your friend already. So anyway, we skip over to that one. And then there's this other thing. The thing about virtual reality is it sort of breaks out into real reality. So this kind of project's been happening, which is a bit weird, and so on. I think we're about done. Finally, the final guy I've met up with is this guy called Hoxie, and I stuck with him for a few days, and then he came on and he was crying the next time I came. And he said I cured him of depression. All we did was goof around for a few days and then go to an exercise class. So, and after that, he then went to his first furry convention, and he came back from that and canceled all of his holidays. And he just booked furry convention for the rest of the year. And one of them is kind of 50 miles away from where I live. And he said, if you don't come to that, I'm going to get in the car, come up to your house and kidnap you. And I kind of think that's like the nicest thing anyone's ever said to me. So there we go.
All right. Well, thank you for your enlightening talk. It was... I had never heard of it as well, but thank you for showing this rule to us. The next person that's going to be speaking is called Commotion, and he's going to tell us about how to manage your own racing team. So a big applause for him.
Thank you very much. I'm a hacker. I also have a workshop, and I do work on motorbikes, cars. And I have some friends who do the same thing. They have their garage, they work on this stuff. They like to program, but if you work as a programmer, coming home and programming more is, you don't have the energy for it. And so we got together talking, and we're like, yeah, we're really good at this working on cars thing. Maybe we should race cars. And the other two guys, they were like, yeah, definitely, we should definitely do that. We should get a race car and compete. And I was like, yeah, it'll be no problem. We'll just find what kind of racing series we want to join. This is the first step to becoming a race driver, really. And also the first step to managing your own race team is you're going to say, it's really easy, and it's not. The second step is, once you figure out what race series you want to join, is, well, actually, the first step is your budget. And we were like, our budget is 0. Of course, we had a little bit of money, but we would like to minimize the amount of money we spend on it. So we decided on a race series that was invented in the UK. They drive the Toyota Aygo, the smallest car on the streets today that isn't like a smart car. And also the C1 and the 107, the Peugeot. They are the same car. They come from the same factory. It's Japanese engineering in a Czech factory. And the trick to it is that it is one of the cheapest cars to get. I was like, yeah, let's do that. Seems like a nice time. So we bought a car. And I said, I remember saying to my two friends, yeah, we'll fix the car up because we bought a used car. Really used car. We'll fix the car up in one day. And then I said, yeah, and then we'll do the racing modifications in one day. That'll be fine. And then we need to install a roll cage. Yeah, we'll do that in one day as well. And then we'll have a race car. And really, that's how you become a racing team manager, is by just like saying things you have no grounds to say. So fixing the car up, it was really, really, really rusty. So we spent, I think, at least a month of like hardcore work doing this. And then installing the roll cage was maybe the biggest project of my life. But it shouldn't discourage you because it was super fun as well. It's just, I got close to burning out on it because it was just cutting the thing. It took three months. And then we've participated in a whole bunch of endurance races, which are some of the most fun I've ever had, really. Except for when you got to the race after 3 months of working, and you roll the car off the platform, and you try to start it up, and it doesn't start. And it's 10 minutes till qualifying. Then it's not so fun. But then usually in these like low budget series, people are very forgiving. So we figured out how to start the car after qualifying had started. And so we didn't qualify, but they still let us race. And on our first race, we placed 5th out of 12 cars, so we were pretty happy with that. I didn't bring any slides because it's sort of a last minute, but if you look for B0 racing, you will see a bunch of examples on how this looks. And if you're interested in racing, that might be a really good way to do it. Thank you.
Thanks. Well, great speakers, all on time. And the next one is going to be fun. This is Galactum, and he will tell us about what could go wrong, the story of how I brought down my school's network on accident. So, big round of applause.
Awesome. Thank you. Thank you. So I'm going to tell you about how I brought my school's Wi-Fi network down by mistake. First, a little bit about how I got there. So My school has really good internet, but terrible coverage. It didn't reach all the way to where I was, where my classroom was. And me being a terrible student, I wanted to, of course, play video games and do stuff during class. So I needed good Wi-Fi for that. So my friend and I wanted to do something about it, to get better Wi-Fi. We saw a free Ethernet port in the wall, and a plan started to form. Here's what we did. We brought a Raspberry Pi, we plugged it into the wall, and we installed Raspberry Pi on it. Now, Raspberry Pi is it's access point software that turns a Raspberry Pi into an access point. It gives you a nice dashboard that you can monitor everything from. It was really good, really easy to set up. And yeah, we configured all of that, and the Wi-Fi was 15 to 20 times faster, consistently, which was really good. And even having a Raspberry Pi, we had some more fun, like stealing files from the network with a spoof file server, but that's another story for another time. But, hang on. But, it was really unstable. Sometimes it would just cut out for no reason. Sometimes it would need to be rebooted for it to work again. And sometimes it would need to be reflashed entirely. Now I'm going to pause here for a second. Some of you might already be able to guess what we did wrong. Spoiler, we didn't. We didn't know what we did wrong. But some of you probably know. So hold on to that thought, and I'll reveal at the end what went wrong. So about a month of it constantly crashing, we decided to do something about it. Well, my friend decided to do something about it. Instead of using Raspberry Pi, he wanted to use OpenWRT. Now, I do not have experience. I did not have experience with OpenWRT at the time. So of course, I was skeptical. I said, can't we just use what we've been doing until now? But then I said 4 words that I now really, really regret saying. What could go wrong? So yeah, we set up OpenWRT on the Raspberry Pi, and it worked. The Wi-Fi was even a little bit faster, which was great. 3 days later, we walk in, and the Wi-Fi's down. We think nothing of it. We had no idea, obviously, that it was because of us. So we thought nothing of it. And even this was quite funny. We SSH'd into the Raspberry Pi, and we used Wall. If you don't know, that's like it broadcasts a message to all logged in users to the terminal. And we used it like a messaging service to talk to each other. And yeah, that was good fun. So 1 p.m. rolls around. School's IT guy comes into our classroom. And he says, my name. My heart stopped in that moment. But yeah, he called me out. I got grilled on a bunch of questions. What are you using that Raspberry Pi for? I didn't know we were doing anything wrong, so I just said we're using it as an access point. He tells me, do you know that it's bringing the network down? I was in shock because I had no idea that it was our fault, and I still don't believe him. So I thought, watch, I'm going to unplug this, and it's still not going to work. I had no choice, and magically, the Wi-Fi started working again as soon as I unplugged it. So, what happened? This is just speculation. Some of you probably will have a better guess, but this is what I understand happened. So, the OpenWRT default config tries to take the static IP of 192.168.1.1. The school router was also trying to take the same default IP. And there was an IP conflict, and everything fell apart. So, yeah, that's why everything went wrong. But now, back to remember when I said it was really unstable before? Why was that? It was a faulty SD card. So, what did we learn? Try to figure out the actual issue before doing random stuff to fix it, and I guess test your storage. Thank you.
Thank you so much for the talk. It was really, really amazing. I think you're going to do really great things in the future. So thank you for that. The next speaker, let me see if I can get my graph. Right. He is called Robin Jansen, and he is going to tell us today about people counting using wireless sensing. Let's see if they can get the laptop plugged in. In the meantime, please sign up to be an angel. We really, really need you during teardown. We're finished. Well, a big applause for Robin Jansen.
Thank you. So, good morning, everyone. I'm Robin Janssens. I'm a PhD student at the University of Antwerp, Faculty of Applied Engineering. I'm a member of the ID Lab research group. And I do my research in collaboration with a spin-off company, CrowdScan, which specializes in privacy-friendly crowd monitoring solutions. That will also be the topic of today's talk. So why do we want to do people counting? The first thing is to provide safety for events, to improve comfort at public transportation applications, or to optimize your resource allocation, or just as a feature in any of your other applications together with other features. So how do we count large crowds which often also have like much more difficult situations like occlusions or flashing lights at a festival, which makes it very difficult to use traditional approaches. So what I'm working on is wireless sensing. Everyone knows how to use radio waves for communication, like Wi-Fi, Bluetooth, or GSM. But you can also use radio waves for sensing. Most of you probably, the best known application is probably radar. But you can also use other types of wireless sensing. So what I'm working on is crowd density measurement. How it works is we use wireless sensors that transmit and receive signals. If the environment is empty, we can measure a certain signal strength on the receiving node. If a person or multiple persons are standing in between, the signal will be attenuated and we will receive a lower signal strength. So by using the empty environment as a calibration, we can take the difference with measurements when people are present in the environment. We can take the difference and we can get our attenuation. We have, based on our research, concluded that the more people are present in the environment, the more attenuation happens in these links, which kind of makes sense. There is still some Gaussian or normally distributed measurement error. So instead of using just a pair of nodes, we use a network of nodes that all receive and transmit signals to each other. So the more nodes you add to the network, the more links you have, and that's kind of a quadratic relationship. So you really quickly can fill your environment with links to get a very reliable measurement. So the advantages of this approach are that we can perform a direct measurement we can just boot up the system, do a measurement, and go back to sleep, which makes the system very low power. So we can use battery-powered sensor nodes to make our system very scalable and very easy to deploy in all sorts of environments, which is much more difficult doing with like things like cameras, for example, or other traditional approaches. So thank you. This was my talk. So if privacy matters, consider wireless sensing as an option. If you have questions or you want to see my extended talk, you can just come to speak to me or send me an email. Thank you.
Okay, that was unexpected. So thank you again. And up to the next speaker, which is, scroll. That is Ripper. And he's going to talk about HawkMass 2026. And I'm really curious what that is. I guess it's something like this. But we'll see in a second.
Great. So, hello everyone. Quick question before I start. Who here likes camping? Bet some of you do, as we are on a camping event. That's great. So, I want to talk about a small event we did in Austria last year, which was the HawkMass 2024, and show a bit what we've got planned for next year. So this was in the end of August last year. We had a castle, like an actual real castle in Ottenschlag, which is a small town somewhere in rural Austria. We had about 350 attendees, so 10% of this camp size. If you don't know where Ottenschlag is, so Austria is about here, and Ottenschlag in Austria is about there, so right in the middle of nowhere. But the castle is amazing, as it looks like that. Was a really beautiful castle. So we had this event. It was organized as a bar camp, basically. So the program was was scheduled each day by the attendees. So in the morning they came together, arranged the talks, arranged the workshops, and then it happened. All the talks that happened are also recorded. So if you're interested what the people were talking about at HawkMass, have a look at Media CCCD. Maybe show a bit more pictures how it looked. So you saw the castle before. Of course, when hackers arrive, it gets a bit more colorful. So it was all lit up with beautiful colors, especially in the night. Even the campground. So we put a lot of work into making everything nice, shiny, and blinky. And even from the air, this was visible. So in the bottom, you see the campground, and the pink lit up courtyard of the castle. Yeah, even in day was amazing. Like really great venue to have an event. Yeah. And yeah, that's, as it was a school, there were proper lecture halls and all that, which was really amazing for the event. And we also had a castle cat that arrived at some point. Yeah, strolled through the event at night and then even at day when it got familiar with the people. Yeah, but enough of today's event, of last year's event. We are planning to do the same next year. We're going a bit bigger. We have a date. We have a new design, and we have a new exciting location. It's not a castle anymore. The only thing I can say as of right now, it's a completely new and even more exciting location than a castle. It's hinted a bit by the design. So, yeah, if you know some interesting sites in Austria, you maybe recognize it. And we have a Mastodon account where you can follow us for updates. There will be the location announced somewhat soon. Yeah, there will be, as soon as we have everything figured out, there will be also tickets. Yeah, it will be a bit bigger, about 500 people. I'd love to see some of you there. Yeah, that's about everything. Thank you.
Well, thank you so much, and maybe some people in here will see you around at the event.
Yeah.
Our next speaker is Leo, and he is going to tell us about personal like knowledge systems. I believe, I didn't really understand, but I hope I do afterwards. But he is still getting his laptop set up, so I was asked to warn you guys that there's going to be a lot of rain, possibly at 12. So be careful around muddy areas and grab a raining jacket already, like when you get back, put in your tent, because it will probably rain at 12 and then you have to get a wet tent all folded up. It's really not recommended. So yeah, possibly some rain at 12. And then, are we ready? Not yet? Then I still have time to tell you we need angels for breakdown. We need biking angels. We need people helping with carrying stuff. We need people helping at parking, telling people you can or you cannot go on the car with your car on the train. So yeah, if you haven't done it, please sign up. Especially if you're still here tomorrow, because a lot of people will leave today. But tomorrow we also need people for teardown.
Hello. I've just realized I can't get my talk notes up. Give me 2 seconds. I do love myself some AV issues.
Okay, then I have more announcements to make. I can continue on and continue on. If you haven't picked up your badge yet, there is more information about that in the Signal group chat. So join it, because people have announcements. There are times you can pick it up and you can't. Some people pick it up for each other. So for example, I sent my QR code to a guy from my village and he just got our whole village our badges, which is really great. So there are probably people in your environment that are also planning on doing that. Merch, if you haven't picked it up yet, pick it up, because otherwise it would just go to waste, which would be a shame. So definitely pick it up. And
I think this is as ready as I'm going to be.
All right, then a big applause for Leo, please.
Right, hi, good morning, everyone. Good morning, everyone. So, I'm here to speak to you today about building a second brain, and a second brain which keeps things, takes things from your head and puts them into the computer in a useful and structured way. Now, I think it's safe to say that your brain knows stuff, right? Your brain knows stuff. All the stuff that you know, all the knowledge and information that's in your head is connected in one big, massive graph. And what you do is whenever you need to use some piece of information, which you've heard before, or you recall it, you traverse this graph in your head, and you take the information and you use it in some way. And that, although it's how humanity has functioned for millennia, is terrifying. Because your life has built-in key man risk. We forget stuff all the time. Tracking what we know is a pain because we store it in a bunch of different places. But arguably, even worse than that, if we know we have a piece of information, we can't find it because we've forgotten where we stored it, that's even worse. It's like the life equivalent of losing your keys. And so I set out to fix this system, and that taught me, and that forced me to think a lot about how I use computers and what I use them for. And I think when we build systems for our own personal consumption, don't worry, I'll show you in a minute, but when we build systems for our own personal consumption, we think about what the parameters are. We think about the inputs, the outputs. We think about how it processes things and stores things. And so for my system, I wanted to store data in a structured way, so I have an idea of what's going on. I want it to tell me what to do. I want it to meet me where I am on my phone and on my laptop, which means that there's no Emacs, no Vim, nothing text-based, nothing Markdown, no YAML files. I'm so sorry to all the Emacs fans in the audience. It should allow me to customize it without being infinitely configurable. It needs to avoid information overload and present things in a structured way. It needs to be free and open source. It needs to have an API. It needs to be self-hosted so I can preserve it for all eternity, and so on and so forth. And thinking about how I use computers now, that forces me to think about what I believe as a person, which is arguably even more terrifying. We all have a belief system based on where we grew up or life experiences, who's loved us, who's helped us, who's been kind to us, who's hurt us, who's been around us, whether we recognize it or not. And so I took some time and wrote down what I believe as a person, which that reflective experience is really, really interesting. And I found other people do this as well. They write down what they believe, and they share it with other people. And that's the foundation of human knowledge. There's a really, really interesting document called the Feminist Server Manifesto, which talks about how, which effectively interrogates how we use computers. And I'd recommend anybody here give it a read. I'd love to read it now, but unfortunately they're showing me a time card, which means I need to shut up. Now, on the system I built, one half of it is a task tracking system like Trello or Jira. Anybody here familiar with Jira? Great, lovely. Do you like Jira? Brilliant. Well, you'll love to hear that I, of course, have burn-down charts. I hate this so much. I have burn-down charts, and I organize everything in my entire life into weekly cycles with work items and burn-down charts, and it's glorious, and I love it. And the other half of it, of course, is a personal wiki. So this is where I keep all the stuff that I know, right? This is where I keep, well, this is the public version that you can see, but this is where I keep all the stuff that I know, right? I built out this collection of documents about me, about my personal processes, about my home lab, about hiring me, about what I watch, about what I'm writing about. And I also have a portion where I organize the rest of my life and store what I know and all that. It's like 1 minute left. Okay, lovely. I thought I was 2 minutes in. No, anyways, it's a really cool system. And if you want to know more, unfortunately, I'm being kicked off the stage in 1 minute. So come up to me, give me an ask me how I've built it. I'll be giving an extended conference talk about this in October, also in the Netherlands. So yeah, so come say hi. Thank you very much. Thank you.
All right, Leo, thank you so much. It was really, really cool. I learned a lot. That was the last lightning talk for today. Yeah, I know, really, really sad. Thankfully, there are still a couple talks on the program, including the closing. But before you go to the closing, please take care of your trash at around every trash in an area of 10 meters from your parking spot. Take care of that. Wash your hands well and often, because it would be a bummer to get sick on the last day. And again, it might rain in a bit, so get rid of your tent already. Thank you.